Hi everyone, welcome back to second semester. This is for geometry students. This is chapter 5, day 1 of right triangles, introducing sine and cosine and adding that to our tangent toolkit. So let's get started. First thing that we're going to cover are just going over our learning targets, but you should look at your toolkit that you have and is also on the online textbook, so something that you can add to and just take notes with. You're going to learn about sine and cosine today, and also just some other strategies for special right triangles, and also that can be used for like reference angles and whatnot on a unit circle. This is what your triangle toolkit looks like. You can find that either in the packet you picked up at school, or you can find that on the online textbook. So today's objectives basically talk about ratios for sine, cosine, and tangent. Let's do a little bit of review first. But remember, though, that when we're looking for sine, cosine, and tangent, and we're using that for acute triangles, these are also right triangles. They have to be right triangles. Okay, some ratios for special right triangles. So we went over this before, but we're going to introduce this again. This is what we call a 45, 45, 90 special right triangle. So could be X, this could be also X, because the angles are congruent, that means that the opposite sides are also congruent. So that would be X, X, and this would be X root 2. All right, so if I said that this was 5, this would also be 5, because these lengths are the same. So 5, 5, this would be 5 root 2. Or 3, this would be 3, and this would be 3 root 2. If this was 7 root 2, these would be 7, and that would be 7. For a special right triangle that's a 30, 60, 90, I like to call the value opposite 30 degrees A, but that's going to change, and you can call it other values, but I like to call it A. Across from the 90, though, is going to be 2A, and across from the 60 is going to be A root 3. Be careful of that, because a lot of people think that because 60 is twice 30, that's going to be 2A, but that's not. Across from the 60 is A root 3, across from the 30 is A, and across from the 90 would be twice A. So if this was 5, this would be twice A, so that would be 10, and then across from the 60 would be A, which is 5, and then that'd be root 3. If this was 4, this would be 8, and this would be 4 root 3. If this side was, let's say, 16, then that's 2A, right? So I can always set it equal to that value. So that means A is 8, so that would be 8. And then across from the 60 would be 8 root 3. So other ways to do this is this. There's two ways to solve a problem like this. For example, if this is 8, I know that this is going to be X, X, and this value on this length is going to equal X root 2. So I could set at X root 2 equal to 8, meaning I'm going to divide by root 2. So I'm going to get X equals 8 divided by root 2. Well, I'm not going to leave a root on my denominator, so I'm going to multiply that by 1 in the form of root 2 over root 2. And so that's going to give me 8 root 2. Oops, let me write it the other way. Let me fix that. And so I would write that as 8 root 2 over root 2 times root 2 is root 4, which is 2. And then 2 divides into 8 4 times, and so this would be just 4 root 2. So if this is 8, then this side here would be 4 root 2, and this would be also 4 root 2. Something to consider, though, all right, is this, that if you forget this little trick here, all right, you could also just say, well, I know I can use Pythagorean theorem. X squared plus x squared is equal to 8 squared. So that's 2x squared equals 64. So x squared equals half of 64 is what, 32? And then I'm going to square root both sides, and I get x equals, well, root 2 is the square root of 16 times root 2, which is 4 root 2. So I could also do it that way, okay, because for a 45, 45, 90, you can always use a Pythagorean theorem. You can't do that with a 30, 60, 90, but for a 45, 45, 90, you can. But there's also a relationship that I want to talk to you about with this 8 equals x root 2. and the answer, which was 4 root 2, which means that if this was 10, then this would be 5 root 2 and 5 root 2. If this was 12, half of that, this would be 6 root 2, and that would be 6 root 2. So there is a relationship in that if you set it equal to the x squared, and eventually you won't need to set it equal to anything, that will just pop up to you, where you take half of this term, so 8 divided by 2 is 4, and then you multiply by root 2. For 30, 60, 90, though, across from the 60, we know is a root 3. So if a is 7, across from the 30 is 7, and then across from the 90 is 2a, or 2 times whatever is across from the 30. So 2 times whatever is across from the 30 is going to be 14. So going to sine, we're going to start with sine. Sine of a is the opposite side over the hypotenuse. And we're always talking about, whenever we find sine of an angle, this is the OH in SOHCAHTOA. So we have this mnemonic, SOHCAHTOA. And this mnemonic says that sine is equal to, sine of an angle is equal to the opposite side over the hypotenuse. Cosine of an angle is equal to the adjacent side over the hypotenuse, and tangent of an angle is equal to the opposite side over the adjacent side. So what that means is, if you're standing here at A, all right, then you could say sine of angle A, okay, is equal to the opposite side, which is little a, over the hypotenuse, which is the side opposite the right angle. So that would be A over C. But if I put myself over here at angle B, and I said, well, what's sine of angle B? You would say the opposite side, which is little b, over the hypotenuse, which is little c. Okay? You're never going to find sine, cosine, or tangent of the right angle. Don't do that. For cosine, it's the adjacent side over the hypotenuse. So if you put yourself here, and you said, okay, here I am at angle A, and I want to find cosine of angle A, then that's going to be the adjacent side, which is little b, over the hypotenuse, which is c. And then if I put myself up here, okay, at angle B, then I would say cosine of angle B is equal to the adjacent side, which is little a, over the hypotenuse, which is c. Now, keep in mind, tangent doesn't use the hypotenuse, but both sine and cosine do. So for tangent, if you put yourself here at angle A, you would say tangent of angle A is equal to the opposite side over the adjacent side, which is B. So the opposite side over the adjacent side. If I was sitting at angle B, I would say tangent of angle B, so here I am up here, is equal to the opposite side, which is little b, over the adjacent side, which is little a. And that's your TOA, opposite over adjacent. So an easy way to remember this is what we call, it's a mnemonic. So it's just a way to, help you remember sine, cosine, and tangent. So they say sine is opposite over hypotenuse. So depending on, here's A, here's B, and here's C. Sine is the opposite side. So remember, it's the side opposite. That's the side opposite. And if this is angle A, the side opposite is little a. If this is angle B, this is little b. And this is angle C, that's going to be little c. So if I'm saying sine of angle A, that's going to be the opposite side over the hypotenuse. So sine of angle A would be A over C. If I said cosine of angle A, so cosine of angle A is going to be the adjacent side, which is B, over the hypotenuse. And both sine and cosine use the hypotenuse, whereas tangent of an angle only uses the opposite side and the adjacent side. And of course, it depends on what angle that you're standing at, okay? So a little practice with sine. I like to put myself at the place where it says, so sine of f, sine, here I am. Sine is opposite over hypotenuse. And remember, this is a 3, 4, 5, one of our triplets. Opposite over hypotenuse, so that would be just 3 over 5. if I wanted to find sine of x, now I'm here, opposite over hypotenuse. So that's going to be 12 over 13. And then sine of y is if I put myself here, and that's going to be, again, opposite 5 over 13, opposite over hypotenuse. Practice with cosine. Cosine of f, you're here. Cosine is the adjacent side over the hypotenuse. But in this problem here, they omitted this adjacent side, so I need to put that in. That's a 4. If you forgot that this is a 3, 4, 5, then you can use the Pythagorean theorem to solve and find that x is equal to 4. Okay, and so that would be 4 over 5. Cosine of x, so now you're here. Cosine is adjacent, the 5 over the hypotenuse. And cosine of y, again, adjacent, not opposite, but adjacent over the hypotenuse. This is my hypotenuse. My hypotenuse is always opposite the right angle. So that would be 12 over 13. Something to remember too is that your hypotenuse is always has to be the longest side. And so remember that if you end up with a hypotenuse bigger than a side, then there's something wrong. Tangent of f, so here you are at f, tangent, opposite over adjacent. So that would be 3 over 4. Tangent of x, so you're here, tangent of x, it's going to be opposite over adjacent, so 12 over 5. And this is totally fine to leave that like that. Do not change that into a mixed fraction. You need to leave that. Tangent of y, so now we're here, tangent opposite over adjacent. So that's going to be 5 over 12. So for these problems here, we're just going to write a ratio. But before we do that, I noticed that they omitted a side. So I'm going to put that in. That's a 3, 4, 5 again. So sine of x, so you're up here. So sine of x, sine is opposite over hypotenuse. So that's 3 over 5. Cosine of x is adjacent over hypotenuse. So that's 4 over 5. And tangent is opposite 3 over adjacent, which is 4. Now for sine of y, move yourself and put yourself down at the bottom. So now you're here, okay? And so for sine opposite, so it's the opposite side of the angle. So that's the side, see that? It's like if you put your arms out and then let that Terminator hands. It's like what is holding this in, right? So that's going to be the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite, which is 4, over adjacent, which is 3. So state two different equations that could be used to solve for x. So now we're getting into solving the equation. So I'm going to put myself at this spot right here where the angle is given, okay? And I have to notice that here's the opposite side from where I'm at. This is what we call the adjacent side, and this is the hypotenuse. So given that this is the adjacent side, right, and I have the hypotenuse, but I don't have the opposite side, you can think about your mnemonic, which is SOHCAHTOA. Which one uses adjacent and hypotenuse? That's this one right here, which is cosine. So then I would say cosine of the angle. You always put the angle next to the cosine, not next to the word. So it's going to be 47 degrees is equal to adjacent side, which is x, over the hypotenuse. And then simply all you have to do to solve this is to cross multiply. And so we have a 1 here. So this is going to be x equals 13 times whatever cosine of 47 is. And so remember also that when you're taking sine, cosine, or tangent, you are actually approximating. So that means that your answer is going to be a little bit off. So it's approximating. So we're going to go, and make sure your calculator is in degrees. So we're going to go cosine of 47 is equal to, and then we're going to multiply that by 13. And I get 8.85, so I'm going to go with 8.9. So about 8.9, okay? And so that being said, now what we're going to do is, this is asking me to state two different equations. So now I'm going to remove myself from that side. Okay, and now I'm going to put myself over at this other angle down here. All right, and in doing that, whoops, where am I at here? All right, so now I'm going to put myself here, okay? And I need to remember that I got to figure that angle, this angle here, that's just going to be 90 degrees minus 47. So we have 90 minus 47, and that's what, 43 degrees? So that's 43. So now, from this angle, from this perspective, I can go, I have the opposite side, and I have the hypotenuse. So I also could do this, right? I could say what uses opposite and hypotenuse? Sine. So I can say sine of 43 degrees is equal to x over 13. And then I would cross multiply again, and I would say x times 1 is x is equal to 13 times sine of 43 degrees. And so that sine of 43, so, I can show you on the calculator. Let's find sine of 43. So let's go sine of 43 equals, and then I'm going to multiply that by what? 13. Okay. So I'm multiplying that by 13. So I'm going to go times, and then 13 equals. So I get 8.86, so that's about 8.9. So what that's done for me is it's given me two different options, right, that I could use in order to solve my equation for x. All right, I could do it with sine or cosine. So here's a word problem. It says, when traveling around San Francisco, one each should climb several steep streets. One of the steepest streets in San Francisco is actually called Filbert Street. It has a slope of 31.5 according to the guidebook. So that's the 31.5 degree. That's a slope angle, is what they said. Once she finished walking 100 feet up the hill, she decided to figure out how high she climbed. And so remember, this is actually our slope. You know, remember, this is the change in y over the change in x, rise over run. I want to find out first this value here. So we're just going to call it, let's just call this y for right now. And if you're standing here, then you're going to go, well, that's the opposite side, and this is my hypotenuse. So which trig function uses opposite and hypotenuse? Well, that's going to be sine. So we're going to say sine of the angle, which is 31.5 degrees, is equal to y over the hypotenuse, which is 100. So I'm going to cross multiply. Y is equal to 100 times sine of 31.5 degrees. Okay, so now in doing that, 31.5 times 100. So we're going to go, for this problem, I'm going to say sine of 31.5 equals, and then I'm going to take that value and I'm going to multiply it by 100, and I get 66.3. And so what that means is that the rise for my problem here, what just happened? That means that the rise for my problem is, I just lost it, 66.3. So that's going to be 66.3. So this is 66.3. So keep in mind, too, that when I'm doing this, so y is approximately 66.3, you're also finding the run, right? You've got the rise over the run. You could use Pythagorean theorem, of course. You could say x squared plus 66.3 squared is equal to 100 squared. You absolutely can use Pythagorean theorem instead. I'm going to finish this off by using cosine, because now I want to find this side. I'm not going to use the Pythagorean theorem. And so now, in order to find this adjacent side, which is right here, okay, I'm going to use cosine. So cosine of 31.5 is equal to the adjacent side over the hypotenuse. And I'm going to cross multiply, and I'm going to get x is equal to 100 times cosine of 31.5. And let's see what I get. Use your calculator. I'm going to go cosine of 31.5 is equal to about, I think I get 0.85. And then, of course, timesing that by 100, you get 85.3. So x is approximately 85.3, and y is about 66.3 also. For this problem here, we want to solve the change in x, which is, that value going across. So it says use a change in x to find the rise. So for the triangle shown, we know that sine of 60. So what they did was they said this, okay, if you were here at a 60, 30, 90 degree right triangle, and across from the 90 is 2a, right? Remember that? So that's going to be a is equal to 3, which means across from the 30 is 3. Then across from the 60 is going to be a root 3, or 3 root 3. And so what they said was that the sine of 60 degrees is root 3 over 2. And what they did was sine, so here you are, here at this angle. Sine is opposite over hypotenuse. So sine of 60 degrees is equal to the opposite side, 3 root 3, over the hypotenuse, which is 6. And then by reducing this, 3 and 6, I get sine of 60 degrees is equal to root 3 over 2. So what they want to know is, what are we trying to, oh, they just want to know what that value is. And keep in mind that if this is 1 here, this means this is also 30 and that's 60. And you could have used that as well. Across from the 30 is a, across from the 90 is 2a, and across from the 60 is what we call a root 3. So that'll be a root 3. Cool. Okay. So in order to find the trig ratios, which what I was just doing, so here I am. 60, that means this is the 30 degree and this is the 90. So 30, 60, 90. And so at 60 degrees here, if you put yourself at the 60 degree mark, cosine is the adjacent side over the hypotenuse. So this is going to equal 1 over 2. Sine of 60 is the opposite over the hypotenuse. And so that's going to be root 3 over 2. Okay. Now, if you move yourself and you put yourself on the other end, okay, of the 30, 60, 90, and I'm now going to be at 30 degrees. Here I am, here at 30. Opposite sine of 30 is the opposite side over the hypotenuse. And so this is 1 over 2. And cosine of 30 is the adjacent side over the hypotenuse. So that's root 3 over 2. And so what you want to look at are these two functions here. See how it's sine of 60 is a half, and sine of 30 is equal to a half. And you also know that cosine of 60 is also equal to a half. So that means that sine of 30 is equal to cosine of 60 degrees. And we actually call those cofunctions, and that's kind of a cool topic. We're not going to do too much of that in this class, but that's just something to be aware of, that these are equal to each other. Likewise, sine of 60 is equal to cosine of 30. Okay, so we're going to try to find BC, which is this length right here. We're going to call that little a because it's opposite angle A, and AC, which we're going to call little b because it's opposite angle B. So we know that across from the 90 is 2a. So now you can actually use this by, you can use this, the shortcut, like I was showing you with the special right triangles, or you could do this the long way. The long way is basically saying, if you put yourself here, and I want to find little b, I'm going to say sine of little b, right? Sorry. I'm going to say sine of the angle, it's always the angle, sine of the angle, which is capital B, but I'm going to call it 60, is equal to the opposite side, which is b, over the hypotenuse. So b is equal to 7 times sine of 60 degrees. Now, depending on whether or not you're going to do this as an exact value, or if you're going to do this as an approximation. So let's start off with an approximation. Sine of 60 is 0.8660. And then I'm going to take 0.8660 and I'm going to multiply that by 7, so times 7. And I get 6.06. So B is approximately 6.1. Okay, so this is about 6.1. Across from the A, or just this little a here, now I'm going to use cosine of 60 degrees. In order to find the adjacent side, I'm going to go A over adjacent over the hypotenuse. So I'm going to have A is equal to 7 times whatever cosine of 60 degrees is. So A is equal to cosine of 60, well, that's a half. We already knew that. So 7 times 1/2 is going to be 7 times 0.5 times 7 is 3.5. And so we have A is equal to 3.5. So that's this value here. Now, a couple of things of note. Once I have two sides, I can use the Pythagorean theorem. Okay, I don't have to use sine, cosine, and tangent twice if I already have one of the sides. Secondly, these are decimal approximations, that is at least. There is another way that I showed you in the beginning of the video, across from the 60, across from the 30, and across from the 90, this is 2a. Well, if 2a is 7, then a is equal to 7 halves. 7 halves is a is opposite across from the 30. So that means that a is 3.5, which means that across from the 60 is a root 3, which makes that 3.5 root 3. And if you type this in your calculator, you're going to get that to be 6.1. But the point is that 3.5 is equal to 7 over 2 root 3. And so what I'm saying is this is what we call an exact value, because it's not a decimal approximation, where this is a decimal approximation. Okay? All right. SOHCAHTOA, we want to solve the triangle. Okay? So we know that we have put yourself, for this we don't want to solve the whole thing, we just want to solve for B. So this is going to be adjacent. So we're going to say cosine of 37 degrees is equal to the adjacent side over the hypotenuse, which is 8. So I'm going to cross multiply. I get B is equal to, it's B times 1, 8 times cosine of 37 degrees. So 8 times cosine of 37, so I'm going to go cosine of 37 times 8, and I get about 6.4. So B is about 6.4. And I'm done because they only needed one side. I want to find A here. So if you were standing here, A is opposite. So that's going to be sine of 23 is equal to A over 15. I'm going to cross multiply. I get A is equal to 15 times sine of 23 degrees. So A is approximately, so I'm going to go sine of 23 degrees. I get about 0.3907. And I'm going to multiply that by 15. And I get 5.86. So we're going to go with about 5.9. And that's my answer. For these three problems here, we're going to solve for x. Again, for this problem here, put yourself at the angle. And so here, this is adjacent. That's opposite, but we don't care about that. And that's the hypotenuse. So we're going to go, what uses adjacent? That's cosine. So we're going to say cosine of 17 degrees is equal to the adjacent side over the hypotenuse. Now, for this problem, though, keep in mind, I actually have to, I am going to be cross-multiplying. I'm going to definitely be cross-multiplying, and then because the x is on the denominator, that means that I'm going to have to divide as well. So when I cross-multiply, I get x times whatever cosine of 17 is, and that equals 3. So x is going to equal 3 divided by whatever cosine of 17 degrees is. Now, keep in mind, too, that when you, and this is going to be an approximation, when you divide this, you need to put these in parentheses. So this is 3 divided by cosine of 17. And so I'm going to say 3. I'm going to go divided by, you need to put a parenthesis. Oops, not that way. Okay, let's try this again. 3 divided by parenthesis. I'm going to go cosine of 17 degrees. And I get 3.13. So we're going to stick with 3.1. And so, uh-oh, what just happened? Where are we at? Here we go. So this is about 3.1. For this problem here, you do have choices, right? If I were to put myself at this corner here, right? Opposite. It looks like I'm going to use sine because that's opposite. So I'm going to go sine of 25 degrees is equal to the opposite side over the hypotenuse. So I'm going to cross multiply, and I'm going to say 9 times sine of 25 is equal to x. So sine of 25 times 9, and I get about 3.8. So x is about 3.8. And so that's my answer. However, I do want you to remember that, there's 2 angles in every triangle. So if I went 90 minus 25, 65, there's 2 angles that I can use. I'm not going to use the 90 ever, but I can use this angle here, which is what, 65? And I could put myself here instead. And I could say, because that's adjacent, so I can go cosine of 65 degrees equals x over 9. I totally can do that. So you have options when you're doing these problems where you can use multiple different types of, ways to solve this, okay? For this problem here on the bottom, this one is this is another, all of these are right triangles, but let's see. We're going to use, where do I want to put myself right here? Okay, and so I'm here at this angle, and this is the opposite side. So opposite and hypotenuse, the O and the H, that's your sine. So I'm going to go sine of 53 degrees is equal to the opposite side over the hypotenuse. I'm going to cross multiply. I get y equals 5 times sine of 53 degrees. And so y is equal to, so I'm going to go sine of 53 equals, and I'm going to multiply that by 5. And I get 3.99, so about 4, actually. So I'm going to go about 4, okay? So that's how you do that. 3 different problems here. We want to find x, and x is a side, and h, my hypotenuse, is the 10, okay? So if we're here, then that means that this is my adjacent side, and that's my hypotenuse. So we're going to use cosine of 20 degrees is equal to x over the hypotenuse, which is 10. And so we're going to go cosine of 20 degrees equals and times 10. And I get about 9.4. So that means x is about 9.4. For this problem here, I'm going to put myself at this angle here. And so that's going to be opposite and hypotenuse here. So I'm going to say sine of 25 degrees equals 29 over x. And we're solving for x, which basically means I have to cross multiply and then divide. Meaning, so I'm going to go x times sine of 25 is equal to 29. So x is equal to 29 divided by sine of 25 degrees. And so keep in mind, 29 divided by, make sure you're using parentheses, sine of 25, I get about 68.6. So x is about 68.6. And lastly, we have this problem here, which is kind of cool. Looks like an isosceles triangle. And with that, and I know it's isosceles because of the 2 congruent sides, which means that this angle has to be the same angle as this, because the angles opposite congruent sides are congruent. So what's 180 subtract 50? So that looks like it's 130, right? And if I were to divide that by 2, I'm going to get, what am I going to get? 65 degrees. And so what that means is that both of my angles are 65 degrees. See how that worked? So this is 65, and that's 65. We just had to use a little 180 degrees minus 50 degrees, and we got 130. We know that this angle plus this angle have to add up to be 130 degrees, and we just had to split that up by 2. So this one is just a little review problem. This is find the area and the perimeter. So first of all, the area of a trapezoid is going to be equal to the height divided by 2 times the sum of the bases, okay? So that means the height, which we see as 5, and keep in mind that has to be perpendicular. So that's going to be 5 divided by 2 times the sum of the bases, which is 10 plus 30, okay? And so that's going to be 40. So we have 40, and we have that times 5, and we have divided by 2. So I'm just going to take 2 and divide it into 40 and get 20. And then 5 times 20 is 100. So the area is units squared. The area of my trapezoid is 100 units squared. So check. Now we have to find the perimeter. The perimeter means I have to add up all the sides. So in order to find the perimeter, it's like you're walking. Here you are, right? And you're just like, you take yourself and you're walking all the way across, down, across this way, and then back up. That's what you're doing. And so it basically like a little Pac-Man. Oh, I should use a Pac-Man. I got it. There we go. Pac-Man. Oh, and it should be yellow, totally. And so what's happened is like you're basically coming across and down and over and back up. So it's like 10. Oh, can't see that. So it's like this. It's like 10 plus whatever this side is plus 30 plus whatever this side is. Now, what you need to remember, and I'm guessing I should actually preface this with this being an isosceles trapezoid, which then would mean that if this is 10 here, so is this. And so that would be 10. I'm guessing, actually, maybe it's not. Let's see what happens. This is 45, 45, 90. That would mean that that's a 5, that's a 5. And that would be a 5 root 2. So I'm wondering, hold on a second. That's 10. Take away 10. Yeah, so this is an isosceles, but that's okay. That's okay. Let's get this going back here. Let's see, where am I at? All right. And so, where's my eraser? Okay. Not isosceles there. I should have probably given you the other side then. All right, we're just going to say that's 5 root 2. We're going to say, we don't know this side then. Let's see, if this is 5, and we know the whole length is 30, right? So that would mean that this length here, that's 10, and that's 5. That would mean that this length here would have to be 15. Does that make sense? Let's see, if this is 10, and this is 15, that's 25, plus 5 is 30. Okay, so that works. So then, in order to find this side, I know that's 5. So actually, for this part of the problem, I would need to use Pythagorean theorem. So let's do that. So 5 squared plus 15 squared is equal to the hypotenuse squared. So we've got 225 plus 25. What is that? 0, 1, 50. 250. Okay, and then the square root of 250, the square root of 250, which is the square root of 25 times 10, which is 5 root 10. Oh boy. Okay, so this is what we know. We know that this side here is 5 root 10. This side is 5 root 2. And let's figure out what our values here is, because this value is a side and this is a side that we need to put in. So here we go. Perimeter equals 10 plus 30, so that's 40, plus our 5 root 2, which is here, plus our 5 root 10. And that is the perimeter. And that would just be units, because it's not units squared, because we're not multiplying base and height. Like that. Okay, For these problems here, these are just find sine, cosine, and tangent. They're just more review. If you feel like you could use the review, keep doing this. We've got sine of 28 is equal to x over 19. I'm going to set all these up first. We have always put yourself at the angle. And so this one's a cosine one. So we would go cosine of 61 is equal to 18 over x. For this one, I'm going to put myself here at this angle here. And I would say I'm looking for, opposite, and this is adjacent. Notice I don't have the hypotenuse. Tangent. So this one would be tangent of 42 is equal to opposite over adjacent. And this one is, I'm looking for the hypotenuse. And so I'm going to put myself at my angle. And so that's opposite. So we're going to go sine of 25 equals opposite over hypotenuse. And so for all of these problems, you're going to cross multiply. You're going to solve these to solve for x, but just the hardest part, I think, is also just, setting it up. Sometimes you do have to do two steps. Like on this problem, you would go x times sine of 25 is equal to 6, and x equals 6 divided by sine of 25. I do want to caution you that you do need to remember to use parentheses. I know I sound like a broken record there. 6 divided by sine of 25. So parentheses, sine of 25. I get about 14.2. So this is about 14.2. All right. This one, I don't have to divide. I just have to multiply. I get x times 1 is x. And 12 times tangent of 42. So x is approximately tangent of 42 times 12. And I get about 10.8. So x equals about 10.8. Okay. Just finishing up here. More of these same problems, but these are practice for special right triangles. So remember 45, 45, 90s, x, x, x root 2. So 5, 5, 5 root 2. Across from the 30 is your a. Across from the 90 is 2a. So I can say 42 is equal to 2a. That means a is equal to 21. So across from the 30 is 21. And across from the 60 would be a root 3, or 21 root 3. This is a 30, 60, 90 again. Across from the 90 is equal to 2a. Across from the 30 is a. So if a is 8, then across from the 90 is twice that. So that would make the x right here 16. So this is just a review. You've got your 3 trig ratios. You can use them to solve missing sides. You can use them to, for word problems, and everything is based on the angle. And of course, you've got your rise over your run, your y over your x. Your hypotenuse always is going to be, regardless of that, the hypotenuse is always opposite the right angle. But you can move yourself from the other two angles depending on, what you're trying to find. All of this, at this point, your toolkit should include these values: Pythagorean theorem, tangent, sine, cosine, and tangent. And also, I would start putting in my special right triangles, which are your 45, 45, 90, and your 30, 60, 90 triangles. So we did a lot of sine and cosine ratios. We talked about special right triangles, which are not going to go away. This is something that we're going to do constantly over and over and over again. And also talking about, moving yourself from different parts of the angles. You have a 3-question exit ticket on Canvas that is due right now, or today. And I'd like you to start working on that as soon as you can. It'll be due by midnight. But you have the worksheets that front and back that are due the next time I see you, which will be, well, actually, they'll be due by Friday. So really keep in mind to keep up with your homework. Even try to work ahead if there's ever if you ever have a chance. Thanks so much for helping. I hope this helped you.